to welcome back, friend, to my another video. This time, very interesting topic: architecture trade-off. So, whenever we design any system, be it a cloud architecture, generally there is a trade-off. Okay. So, in real life, also you will notice there are a lot of trade-offs we do. Uh, if you want to do something, you may have to compromise on other things. So that's general thing. So here I want to cover all these things, and I will cover very slowly because I these are very interesting topic, and I strongly believe this concept was there for long time, and it will continue to stay for long time, even after use of AI or any other future technology. This is like uh, very first principle based, and it's here to stay. So for us, for everybody, it's very important to understand what all these trade-offs are. And so once you get a fair understanding of this, it will help you making very important decision, be it in your business, in real life also, in your personal life also. These are applicables. I'll come to that. So in general, the whole design is basically balance itself. So that's why I mentioned here balance by design on the top side. Now anything we do, there will be a counter thing uh, is there for every action. There is an opposite reaction, we know, right? So same thing in in doing and applying anything in our uh, be it your system design or if you're working on a cloud, those things are applicable. So the first thing generally comes is cost, and then complexity, operation effort, speed, and so on. So I want to go each one by one, and I have primarily listed down these eight, I'll say, dimensions where if you increase or decrease any of them, there is a effect on the other side, and they have some direct relationship in some of the cases, and some of them are like indirect cases relationship. So this the whole grid is 8 by 8, which will be like a total 64 kind of combinations. If you think that way, 2 raised to 64, it's like you can imagine so if I take this one particular cell, there is a two possibility like increase or decrease in so it's like think about 0 and 1 and you put it on this grid. So the combination can be 2 raised to uh, 64. Of course, there is a in between the goal section you can ignore, but that kind of possibilities are there, and that's a huge number. Okay, and uh, so the and what here I have selected is also, I'll say, limited, but these are very common or generally used in architecture design. There are other dimensions also, but those I don't want to like cover here. Reason being, they may be useful in some cases, but generally not used. Okay, so this 8 dimension, I will say, cover 80% of the work which we do in architecture designing, system designing. It's covers that. Okay, and to re- so to remember this, it's like this. I come up with a very nice memory aid. It's called Crazy Cats on Skateboards Steal All Cheesy Wood. So that way I can remember all these 8 words and uh, try to whenever in discussion or forum I can recall that. So how did it relates? Cost, generally when we think about cost, it makes us crazy. So the word crazy came from there. Complexity, anything is complex, and so the cats are generally a complex animal. So what they behave is very unpredictable in some cases. So that's complexity. Operational effort. Okay, so it is more of a on and if you think about like cats on skateboard, it requires certain effort for cats to be on skateboard. So that way you can think on operation effort. Skateboard is like when you are on skateboard, you generally increases your speed versus if you're walking. Uh, so skateboard there, and that you can relate with the speed. Security, whenever you think about security, the steel word is related, so that goes. Availability is as something has to be available. Is word goes with all. All are available means everything is available kind of thing. So that's relates. Consistency and the word cheesy is basically if you order generally if you order cheese pizza, it is of a particular format. There is a standard format, so it's consistent. So that way you can think about cheesy. Flexibility. Uh, so when you it's basically food are available in very different forms, and you can change it to customize it as you like it. So that's the kind of a flexibility. So this crazy cats on skateboard steal all cheesy food. So if you remember this sentence, you will remember all these eight different dimensions of trade-off. Okay, all right. So let me explain each term. First, what does it mean? And then we will go through this grid and understand what is happening. Cost. Very simple to explain. Anything we do, there will be some cost involved. So cost is like energy to move something here and there. You have to spend energy on it, right? So uh, the, to get certain energy you spend, you need to have you have to spend money for that. So cost is always there uh, for any things you do in this like world. It is always going to be there. Then complexity uh, is basically just opposite of simplicity. There will if you want certain things to operate in certain way, you want certain criteria conditions, complexity will naturally increases. You want more options, more things. That's all about complexity. Okay, anything like not straightforward, you have a multiple routes, if conditions and all those things, those are complex. So more you bring those if true this false then do this that, if you bring lot of multiple cases condition criterias, it increases the complexity. And that's how the life is, right? Life is also pretty much complex, but we want to simplify it and so that we live more happy life. So that's the part of it. Operational effort. This everything we do, we have to it's like for example your mental effort. You want to do something, or it could be a physical effort. Anything put your mind and focus and energy into that. A person, basically a person, a human involved doing some certain thing, that is related to operational effort. Okay, so think about you have a team of developers who is working on anything, and you give some like very difficult tasks to them. Naturally their effort will increase, right? They have to spend more time, they have to focus, they have to do their work more. That's called operational effort. That's why you can think about this image uh, depicting some work needed. Speed is speed is very easy concept. Everybody knows. It's like doing if you're taking like say 10 seconds to do something, and if you reduce the same if you do the same thing in 5 seconds, you are increasing the speed. So for example, you're traveling and anything like you know this concept very well. So in architecture world, it's like you want to transfer a data from one location to other to the user. Like say you're transferring 60 GB of data, 80 GB of data. How much time from region 1 to region 2 takes total transfer time and all that things. That uh, faster it goes, the speed you're increasing the speed. That way you have to think. I think it's very self-explanatory. Security, very important, and across the whole world, this is very critical. Why security? Because you want to safeguard your asset. Just like your home, you put a lock outside, right? To safeguard your asset, so that you can, for example, you live in your house, yet you want to have a lock, you want to have a door and boundaries, so that when you sleep at night, you peacefully sleep. Not now, if you go back century backs, we created safe so that we can sleep peacefully. There is no animal attack that time, no, or any wild animal can attack you. The human used to create a guard so that for example, they used to stay in the cave and be secured there. So that's how the main idea of security applicable in here also. When your data is stored in server, it remains secured. Nobody can uh, uh, move around or change it without proper authorization. So that's the security. Availability is a if for those who are not, don't understand availability as a concept, is basically uh, let's say let's say you want to watch a particular movie. Okay, so is it available online? Okay, uh, so let's say you search for any very particular movie to search watch. It has to be available somewhere stored in the network. Let's say it is stored in a certain country which you are not a part of that country. It is stored in there. And now you want to connect that server and bring so that you can watch the movie. Is that wherever let's say it is stored in some as hard disk drive or as SSD, uh, it has to be running, and it has to be connected to the network. Then only you can avail it. Right. So that is the call availability, to understand availability. Now, uh, for I'll talk more in terms of architecture, how availability is related to consistency. Uh, Something is available to you. Okay, if you try to increase the availability, there is a theorem called cap theorem. Your basically consistency, availability, and partition theorem. If you want to have a availability, you may lose the consistency because of the partition. I will explain this concept, very interesting concept also. So I hope you understood the availability. Then, excuse me, then consistency. Consistency is nothing but we try to say uh, if your data in let's say you have a two database, okay, you have put certain thing, you have written updated that database in region 1, let's say in Europe, okay, and that database is in Europe, and you copied that same database into US. So whatever there in Europe, has to be exactly same in US also. That is called consistency. Now while copying, if there is something lost, uh, or if it is not also lost, let's say data is still transferring, okay, let's say it's a huge data, okay, uh, some of them has already transferred to US, but some of still about to get transfer because of latency and all that. And then for few second, what US number is showing will be not matching with what is there in the Europe database. That is the consistency. Now this is how it's related to availability. I will explain to that. Okay, so how it is related, and we'll come back. The final one is the flexibility. Flexibility. Uh, think about this from the customer perspective. Let's say you have an application. Okay, you have designed an application, and you say that you will have a three color to choose for your web page. Okay, that is very simple application where customer comes, okay, I will only have an option to select three colors. But what if some other customer want a different color? Hmm. That means you have to add another color, or so that other customers wants can be fulfilled. That is called flexibility. To for your system also, you if you want to have more flexibility, means you want to have more options, uh, then you are actually increasing the flexibility of the system. Okay, so this is the in the broad sense, these are the one in architecture design we come across all these things, and then there is a trade-off. Okay, so we'll explain the first one. I will when I am going to explain the first one, you will understand how they are related and how these arrows are there. So let me first explain what does this arrow indicate. So arrow is simply telling, uh, arrow downward is actually telling you uh, you want to reduce the cost. Okay, you want to decrease your expenditure for certain thing. Okay, that is what you want to achieve. So it's reduce. Upward is increasing something. Okay, now there is certain color coding also I have done. Okay, so you will see this uh, yellowish arrow, upward arrow, is generally in increase in cost or effort. Okay, we'll come to this, so just think about it, I'll come to this. Then downward arrow and color red indicate it is not it is actually decreasing, it is dropping the strength of your system. I will come to that, how it is dropping the strength of this system, but particularly for that dimension. Okay, just remember that word, particularly for the dimension, because the things can be interpreted differently uh, if your case is different. So again, this whole architecture thing is designed from a perspective generally used. We can definitely have any very special case where things can be proven, okay, this cannot be this way, but 99% of the time this will be the case, because it is there for a very long time, and lot of people has worked and implemented and got the result from this application. So okay, the green arrow is like going in your favor, and the middle one which you see, this is nothing but for complexity complex, that's the goal you are trying to achieve. So it is just put the dot over there, you can see these are the dot, I've just put it here. and we have something called dash is roughly neutral, means there is no impact to it. And finally you will see some star over there. Okay, some stars are there. So stars is, which is a signature trade-off, means there is certain um, relationship exists between so for example cost and availability. You see there is a star over it, means there is a very important relationship exists between those two, and it is industrially proven about this relationship. So watch out for this star whenever I go for each rows explaining it. Okay, so let me start with first row. Here actually I will say the my video is starting after those who have already a fair understanding of it. So this is where the real you know cream of the video is. I'll start with the cost. So let's say your organization want to, you already have an architecture, means your system is already designed, running, everything is fine. But business decision has come up that we have to reduce the cost. Okay, reduce the cost because the expenditure is, we cannot bear it. Think about reduce the cost. That's the general, you know, uh, there is a request came from, let's say, leadership. Okay, now how how can you achieve reduce the cost? There is a way you can do it, is either, so first thing I'll say, you reduce the complexity. If you reduce the complexity, that's why the arrow downward, you can decrease the cost. Okay, that's this arrow says. Now I'll come to this green, why it is green. First let's understand what will happen if you reduce the complexity. How can you reduce the complexity and the cost will drop? So since let's say you have a very complex architecture design and you simplified, you said that okay, if I don't need this pipeline, particular pipeline which I'm not using regularly, very less I'm using it, sometime I'm using it, so let's remove this pipeline. So you are actually decreasing the complexity, you are making more simple thing, so you are removing something out of it. Hence you do not need to spend energy or time or effort into that particular pipeline which you are trying to remove. Hence your cost will drop. Okay, you're getting, now you're getting the hope you're getting the relationship. Same thing, we'll move to the next one, which is like effort. Now how increasing effort will decrease the cost? So this is how you have to think. Let's say you are you know you have outsourced certain thing to other vendors to do some certain job. Okay, now because of that, you are not, your team has doesn't have to work on that particular work because you have outsourced it. Now let's say you bring that work indoor, you say that okay, instead of paying outsider, I will take care of it, I will do it by myself. So now your team has to do that work. It is more of your mental effort, and your team has to do that work. Effort has increased, but your cost has dropped because now you don't have to pay to external vendor. So that's how you can relate. Operational effort will increase, but you can decrease the cost. Okay. The other thing is either you compromise on your speed. So simple example, like hard disk drive versus SSD. Hard disk drive is is cheaper compared to SSD, because SSD is a new technology. And uh, so if you move from SSD to hard disk drive, let's say you move your data from SSD to a hard disk drive in cloud, you will compromise on the speed, but your cost will decrease. Again, you can achieve that way. Same thing in different, there are different available in storage also. If I talk about, let's say Amazon AWS, you will see S3 have a different buckets. If you store in S3, different, like Glacier is cheaper versus S3 standard is expensive. So that way, you know, different class of storage is available. Same thing for processing also. If you ask for high speed processor, it will be expensive. So what you could do, you go to low speed processor, so that your cost will decrease. That's why you decrease your speed, naturally your cost will decrease. Hmm. Security also cost you more. So every time you put a guardrail, you have to manage that guardrail. It slows down the system. Lot of layers are there, like firewall. You know, you will have firewall, then all connection layers, security systems, security, protocols, all that things, governance, everything. Managing those things, you have to pay for it. So if you remove certain security uh, levels, you can decrease the cost. But generally, it is not recommended to touch security, because security is the heart of your whole thing. If anything goes wrong, it will be too much cost for the entire organization. So you will see leadership will come up saying that avoid, do not touch the security, but try to do it with other things. Okay, that's how generally a business will ask you to uh, manage this thing. One second. Now I want to talk about very this is the star one. Okay, availability versus cost. So there is an for this particular star one, I have created a image. We'll go to that. We'll explain that. Okay. So the objective was to reduce the cost. Okay. So think about this is availability. So you have a database replicated into different region. Okay. So let's say it's in one is in America, other is in Africa, and other is in Asia. You have a three database, and there also it is have their availability zones replicated. So this is your initial architecture design, but the request came, okay, we have to reduce the cost. So what you can do, you can remove the other database, just keep one database which is near to your location. That way you don't have to pay for this extra architecture, sorry, database, which is a copy of it stored into other region. There is also network cost, read write cost, everything is there. So you remove this, you can uh, you can reduce the cost. The problem is, if you do that, if you have only one database, if it goes down, means the entire system will go down. So in some cases, let's say you have a, developing team who also do a replica of their database. You can say, if you're developing, you don't have to do a replica of it. If it You can have a local copy, and when you push it into database, then then only we will replicate. So those kind of things can be uh, decided by the you know team, and accordingly make the decision. So idea is, if you want to reduce the cost, you can do it by reducing the availability. Okay, and this is a signature trade-off. Most of the architecture architect knows about it. Okay, so then relationship between consistency and cost is not that much, so I don't want to talk much about it. Then flexibility. Okay, cost and flexibility uh, is, like I said, flexibility is like more options given to your customer to do certain thing. So if you remove those features, extra features, maybe let's say you have 100 customers. Okay, there are two typical customer who look for that particular color example which I said, right? So if you remove those thing, you do not have a much impact to your business, because you are actually catering 80% of your customer, or 8 to 90% of your customer. Only like 2%, like 98 I would say, only two customer will not be happy. But since you have to manage the cost, you remove that feature, flexibility from your design, and you will save that extra management cost of that particular product or anything in your design. So that's how this particular things are related. I hope this relationships and everything is clear. Now, same way we will have for complexity, there will be relationship, operation effort, there will be relationship. So for the interest of the time, now I will go a little fast and cover, because now you got the main idea of about it, how it are related, and then we can talk about it. So complexity, let's say your business leader came with you. Our architecture design system is very complex. Let's make it simple. Okay, please simplify it. Remove the unnecessary, criteria, conditions, pipeline going here and there. Make it simple. So here there are direct relationship. If you reduce your cost will drop, your operational effort will drop. Obviously, it's less. It's simple one. You can manage it easily. A simple thing is a direct connections between certain thing. The speed will increase. Consistency will be there because simple. The only thing you lose the flexibility, because let's say customer wanted certain features, you have to drop that. That is where it is a star relationship, a signature relationship between complexity. So I will show you with the image this star relationship. You will understand. So this is how your complex structure is, that certain application connect with that, and then there is a logic and flow, everything. This is how your network was. Now you just made it very simple, and just example. The problem is that there was some relationship, there is certain things available because of this complexity. Those has been gone. Now it is became more of a open-ended stack. Okay, you designed, you think this is right, and that is how everybody has to follow. Okay, this is more of a like a simple thing. You are removing the options available for customers and everything, because you want simplicity. Okay, but that way you actually became more rigid kind of thing. So you cannot be like very simple also in real life. You need to have options given to different people, different needs, right? So that's how you have to balance between complexity and simplicity. Okay, So again, simple. If you reduce the complexity, you are going to lose the flexibility. That's the relationship. Okay. Uh, okay. I hope it's clear. Back to the matrix. Now, operation effort. I'll talk about operation effort. Operation effort. Let's say business said reduce the toil. Means my developers are working hard. They are getting tired. You I want to reduce the effort for my team. So what I can do? So there is a star relationship. Okay, increase the cost. Means what you do, you can give it some of the work to vendors, or make it for in architecture cloud thing is serverless. So managed services. Okay, so what you do, instead of you managing the thing, you ask somebody else to manage it. But when you, as soon as you ask somebody else to manage, they will ask some money fees for managing your stuff. Okay, because they are taking your work, right? So you have to pay them. Your cost will increase. That's the signature relationship. So let's see the diagram, so which will explain you. So here just I'm depicting, it's like a cluster management. Let's say you have a Kubernetes K8, managing clusters. You're configuring this, how much memory CPU for particular workflow to be done. Everything your engineers are doing it. Installing everything, virtual VM machines, everything. Okay, you're doing it. It's too much work for your engineers to do it. Otherwise, what you can do, you give it to the cloud providers. They have a serverless um, thing, which can be, they will manage for you all the thing. You just go simply uh, s- ask for whatever you need it, and they will take care of it from the backend. So that's, but if you do that, you have to obviously pay for that. Okay. All right. Now this is the relationship. Obviously, complexity will, if you reduce the complex, there is a gain. If you, it became very simple for operation. Availability increases uh, if you know give it to other things. Generally, it's uh, there is a gain over there, and there is also, uh, if you decrease the operational effort, you have your flexibility will also decrease, because now you cannot have a control over the thing. So that's the opposite relationship. But the main is this, you can relate to this. Okay, then I just want to highlight these three. You see there is a box I have created. All these three, generally business want to reduce. Okay, cost they want to reduce, complexity they want to reduce, operational effort they want to reduce. Okay, you see, and uh, that's, it's a common sense thing, right? You want to reduce this. Okay, in long run, everybody want to do this. And same, then I have divided other things into this upper, you see this up arrow. All these, generally business want to increase the speed. Everybody want to do things, faster. We want to have a more secured environment, so we want to increase the speed. We want to have our system available all the time, right? So that you can access anytime, whenever you want, from wherever you want. Consistency, we want our data to be very accurate. If you are reporting X in what a certain system, that X has to be reported in other system also. It should not be like Y or Z. So consistency, we want to increase that. We want a lot of features in our products. Okay, we don't want just very simple things. We want, okay, this I want, this also, that also, flexibility. Generally people want different colors in their life. We used to have a black and white TV movies, remember? Now we want colored TV. So once we have color, we want 3D. So extra things we keep keep wanting. So that's the general nature of human being, I'll say. So here, uh, that's why I divided this into these three sections, and you'll see a line separating them. uh, in between there is a line. You see this line? That's what I'm separating it with this. Okay, now let's talk about speed. Business said, okay, I want to increase the speed. System is very slow. Customers are complaining. Can you increase the speed? So answer is yes. Uh, give us more money. We will increase the speed. So that is not generally available. But what you can do the other way, you can reduce the consistency. Basically, let's say you have a database. I'll show you an image. That way I'll explain. Let me show you the image. So this is how uh, consistency versus speed. So if you want to you know get a read request very fast for your customer, okay, so initially let's say you have only one database, which is a primary database. You write into that primary database, and these are the readers. Means user want to write a SQL query and get the information out of it. So they may have to, if it is writing, they may have to wait. Okay, so this is like slow. Okay, so what? But the good thing is, this is one single database. It's consistent. So everybody, when the moment this write is completed, if somebody is asking some query, it will get the exact result, and all of them will get the same result after the write has completed, till the time that this will be locked. Okay, but the user have to wait. But we want to increase the speed. What you can do, you write into one single database, then create a copy of that into another database, which basically reads from here and put it into copy. Now this read replica can be given to like users to read it from here. Instead of reading from here, you read it from here. Let's say this person will read from here, the other one will read from here, and so everybody is reading in parallel. So they are getting some information out of the database. The problem is, uh, somebody has just written here something, it has to copy into other thing. huh? there is just some lag between this. Okay, this lag, or it could be if some failure happens in between, so this read replica will not have the exact what is here in this written here, so it became stale. Okay, that's why it says consistency is down. uh, this is problematic, uh, but the advantage was, I said, na, is you have a read replica, people can read it. So again, you want to increase the speed, you will lose the consistency here in this case. Okay, I hope it's clear. Let's go to the thing. So this is what we covered. Again, I don't want to go into this like speed and this security is indirectly related. We'll come to that. Okay, security, very important topic for the business. Generally, a new policy, a governance framework will come uh, from the authority. Then very important business has to ensure that their systems are secured. Okay, So time to time a new threats comes in this world. So right, so time to time the system also has to be upgraded to ensure it is secured. Now this is always expensive, and it is definitely, if you want to increase the security, you have to spend money on that. Let's say new threat comes, you have to have a new technology to stop that threat. You have to ensure everything, all your servers, everything has been adopted with the new technology which safeguard your system. Okay, so this is obviously going to cost you more. It is security always bring additional complexity, obviously increases your operational effort to manage the security. uh, it uh, it obviously decrease the speed, because one layer of security, every layer of security will slow down the thing. Okay, the good thing about security is the availability, means your system will be available if it is not hacked or corrupted by anything else. That's the advantage of security, so this is a positive thing. Obviously, when you apply security for every features, some features you cannot just open up for everybody because of the threat or whatever the reason. So that's how the the customer will lose the flexibility. Okay, that's the opposite. But I want to talk about this star relationship, which is signature relationship. Let's see the image, that way we can understand better. Earlier, remember, with before SSL, without any HTTP protocols, without HTTPS secure thing, you simply can connect to the server and get the immediately the answer. Now in the modern world, everything, you have a firewall, TLS, authentication, encryption, application layer, and further things are also there. Okay, these are going to slow down, but it is secured, because these are like a locks and safeguard. uh, but again, everything here, there is some processing is happening, CPU is processing something. Okay, when every request come, this firewall is doing something. Here also something is happening, authentication, encryption required some work. Okay, there is processing happening. Memory is not that much, but still used. So this is energy spent over here. Okay, all these things are not like free, so it's costly also, and slow down also. Okay, that's the universal relationship. That's why I want to make it very clear. You want to increase the security, it's going to slow down. Okay, nobody will say that, oh, I will increase the security, speed will also increase. Rarely going to happen. Okay, back to thing, the other one, uh, availability. Okay, availability is like I said now, you want to watch a particular movie and that movie is saved in certain other country, it should be available to you to watch it, right? It should be up and running, it should be in the network with egress on. Okay, so to make your system available, let's say you have a hard drive and you want to put it in the network, it should be up and running all the time, and the copy of your data should be available. You have to do a lot of things. Okay, so it will cost you more. You want to increase the availability, it will cost you more. It will be complex, because you just can't keep a single copy of your hard drive in your single local machine. You have to have a replica copy of it stored into cloud. Not only one single region, it has to be stored in multiple region. It has to have active connection on all that things if you want more availability. um, Availability is not about just like, okay, it will be available after 5 hours. You want it when you want it, like say in the very moment you want it, right? So in like 1 second or 2 second or maybe in couple of minutes, you need that information. So that's the ability. So definitely the complexity increases. Operational effort goes side by side with it, because you have to manage multiple region, cluster and all that thing, their connection network things. Either you manage or you give it to other vendors, still is going to be there. Consistency. This is what cap theorem which I want to talk about. uh, why availability, increase in availability decrease the consistency. Okay, this is the question everybody should ask. How this is related? And so we'll see our image, and from there we'll understand. Okay, let's think about one single database located in one region only. Okay, this is your current state. Okay, but you want to, if you put it all the data into one region, okay, any disaster happened in this particular thing, your database is gone. Anybody like want to access it, cannot access it. Okay, that's why the cloud and everything came into picture, where they said don't store everything in one place, make a copy of it and put it into other databases, and it has to be away from the geographically away, because of natural disaster anything can happen, your region can go down. So if you make a copy through internet connection, right, it through, so it will go from the internet. There are direct connect cables are available also for certain clouds. Okay, whatever be the case, you need to make a copy from region 1 to region 2, region 3, whatever. Process of copying from here to there will be a lack of uh, timing gap. Okay, it's because of the physical limit. Okay, that's why anybody reading in region 1, or let's say, it will not match in region 2 because of the time gap. That's why you will lose the consistency. So if this fails, okay, there is a connection failure happened, obviously it will have a still data. Okay, so failure is possible. That is called partition. Cap theorem, P stand for the like partition. If you partition them, or you can think about a failure in the network connection, those will not be match. Okay, so the main idea again, if you want to increase the availability, you can do this way by making available for the user here, because if this downs but still the copy is there, right, it is available, but it may not be consistent. But there is a new concept come, like eventually consistent means after few seconds, let's say this goes down, okay, but the copy is been stored here, you can eventually uh, get that information after some time. So eventually consistent, that's the idea. Okay, so I hope this is clear. Let's go to consistency. Okay, the consistency, again same thing, both are related. I just don't want to spend too much time. Finally, the flexibility. Okay, flexibility, let's say a customer say that I want extra certain features to be added in your application. Okay, so how you can do that? You can do by, you have to spend some money to bring that additional feature or product for the customer. uh, so the cost will definitely going to rise. As soon as you add another product, let's say you have a 5 product, now you have a 6th product. Obviously it became more complex now. There is you have to integrate everything for that particular 6th product in your system, so complexity will increase. To do that, your developers and everybody has to work it, integrate it. It's going to cost you. Speed will decrease because now you has to uh, the route to multiple thing instead of only 5 thing. Now it becomes 6 thing. Rest of the things are generally doesn't get impacted. But let's talk about the star one, which is flexibility and complexity. I'll explain with the image. Uh, so when you see, generally your developers are developing any app or come up with any idea, it's generally a monolith app. Okay, in their own local machines, everything has been built, tested, running fine, all good. But in real, if you want to move it into production, what you do generally, you make it service thing. You split the work into small services, and then those microservices is managed independently in your cloud, and it has own uh, budget and firewall, in fact a security system, so that service if particular microservice goes down, does not impact all other microservices. So it is more safe for you, I mean for your business. Okay, so if you want to increase the flexibility, that's what I'm saying. If you want to increase the flexibility, you want to add a more product, you definitely have to increase the complexity. Otherwise you cannot achieve the flexibility. Flexibility means adding certain features or product for the customer. So you are doing in a only certain way XYZ, and you want ABC also, extra things also. You that is called flexibility, and increases the complexity. And that's the right side. I'm trying to depict the picture for complexity. Okay, all right. So I hope everybody would have liked this thing. Very interesting. I time to time I come to this you know image, and so for every business request, things will generally fall into this categories, and it helps me to make the decision uh, as needed. So like I said initially, if you think about this like a even for a chessboard, right? It's like 8 by 8 cross 2 raised to 64 combination is possible. That is a huge number. Okay, if you do that mathematically, it's a very big number. Now here uh, I want to, why it's big number, I want to just tell you this way. Here the cost goes down. Now this cost goes down, it's just going down is one signal, like go up is another signal, but between that also there are variable number, right? I want to reduce the cost by X amount, Y amount. Now your think about your permutation and combination number exponentially increases. Okay, so this all this also have is not like zeros and one, it is variable number. Speed or security, everything are variable number. So in fact is very all different kind of combination and permutation is possible in design. Okay, but so what is the benefit of this trade-off matrix is you can understand up and down relationship between all these dimensions, and you also understand now why certain things behave in certain way, and it is not like anything new comes in this world which will change dramatically the whole design. This is there. Okay, so it's very critical for anybody who is, not only for the cloud design, if you're a cloud designer, architect, not only for them but in general also, this is applicable. I can definitely thinking of coming up in future videos where I will talk about real life trade-offs, okay, which will similar to these things, but I will talk about in real life also. You make all kind of trade-offs. Right now also you are doing some sort of trade-off. So moment anything you are doing, some trade-off is already happening in this life. Okay, so with that note, I will close this video. Thank you so much for your time. I hope you like it. If you like it, please share with anybody who want to use it and it will be helpful for them. Please do share. Thank you again. Bye bye.